Okay. So what is breaking strength, Veda? Or breaking point or breaking strength? What is it? Yes, tell me, Veda. No answer. Okay. Veda, you're saying something. Okay, Shirisha, you there?
So basically, I'm joining only before class. I'm not listening that, so I don't know that.
अच्छा, ठीक है. And anyone? What is breaking strength or breaking point? No one? Samhita, Aditi,
So what's the question again?
what is breaking strength or breaking point?
So breaking strength is the length of the wire because due to which like the wire will break by itself, like due to the stress.
It will break by itself.
Yeah, like if like at the given length of the wire, when we put a strain like stress on it, will break by itself. Like you don't have to put a lot of stress on it.
अच्छा, ठीक है. See, this region is actually, I've drawn this so long, so big, but it's not so big. It's very, very narrow region. I've drawn this long to understand. Actually, it is very, very narrow region. Now, like if we have little force also, it will break. So this means what? This is about to break. If you apply a little more force, that means it is going to break. It is going under fracture point. That is what a point, a position. So up to this, it is a breaking strength. Means it has strength to not to break. What is brittle material? What are brittle and what is ductile? Brittleness or ductile or whatever.
So brittle is the ones which are easily broken.
Easily broken. And ductile material.
Something that could be drawn into thin wires.
Thin wires. So if we want, see if I take same material, how to make it ductile and how to make it a brittle material. I want same material to be used as both places. Can we do that? Is it possible? Will it be possible or not? Yes or no? I want to take same material to be ductile as well as like brittle material.
we can take a wire which is ductile and stretch it till its fracture point, and it will break by itself then.
Yeah, that way also we can do. Yes. Nice. Anyone else? What guys, you're not thinking anything? You should think you're you're becoming engineer, right? You're going to become engineer and you should think something extra. You're going for IITs, preparing for
So
IITs,
we
you
can
should
even
think.
heat it, right? Like when we are stretching it, we can supply heat, and more the hotter the material becomes, the easier it will be to break.
It will, see, if we heat that material, it will try to get melt first. It will not break.
Like, no, like we can take something with a higher boiling point, and usually metals with higher boiling point are ductile. And
You
like,
mean melting point.
yeah, and then like when we are stretching it at a point, it won't melt, but it will become, like jelly-like, so we can easily
Break.
break it.
Okay. Yeah, that is also good thing. See, easy way to do this thing is like add with some other impurities. Impurity in the sense, not some non-metal or
Alloys?
non-conducting material.
Is it like
Yes,
alloys?
to make it alloy. So if we make alloys, then it might be possible. Let me connect to charger. 1 second, please. Okay. Fine. So we can make it like to both ways. It's might be possible by adding impurities of like we can make alloys and all that. We can do it if it is required. Fine. Let's come back to our topic. So, so simple way to understand metal with small plastic deformation. They are brittle. Next, we can say metal with large plastic deformation. They are ductile metals. Simple. This, if you remember, it's more than enough. Anyhow, this chapter will have numerical only, but still we should know theory to understand numerical. Do you know what you mean by fatigue? Fatigue. Have you heard this term? Fatigue. In like English, fatigue means like simple terms. If you understand, like how we can say, see, whenever we get so energy loss, when we are running so much, we got loss of energy.
Yeah, sure.
So like we will feel like it will take some time to recover because we have lost almost full energy. Or immediately we are starting exercise and we did so much exercise and we lost all the energy. We cannot walk also. We feel so much hot. Our body is like so much tempted to drink so much water and all that because we lost all our oxygen in our body. Like so we need so much water to fill inside and all that to make us calm. So because we have reached that level, that is fatigue. So simple way we can write here like delay in recovery. This is not like a definition all that. I'm just writing simple words. We don't need definitions. I just want you to understand terms. Delay in recovery or delay in recovery to come to its original strength. Now we won't use strength here because we're not talking about strength. We are talking about elasticity. So original configuration. Uh, by the body or whatever of the body. So you can use your own terms, whatever it is. In short, this won't be permanent. This will be temporary. This loss of energy is not permanent, it's temporary. We can regain its our own strength again. To regain this time or regain this original shape or configuration after recovery, this time is relaxation time. Session time. Then next, we will see all the modulus. Modulus means dependency. Elastic, moduli or modulus. Mode number means moduli, right? Now, elastic modulus, this modulus depends upon main thing, nature of material or property of material, which is used. Material. Next, it depends upon how it is deformed. It is deformed so much, it deformed less, or nature of deformation. Or it is hammered and deformed, or it is melted and deformed. So it depends upon nature of material. Sorry, deformation. Here, breaking strength we already wrote. If we include the stress in at this point, it is called breaking stress, where this system will break. That is your breaking stress. So let's go with the first one here. Young's modulus. Mr. Thomas Young.
Could you scroll up?
हाँ इधर कुछ लिखा ही नहीं है.
No, sir. Just I wanted to see the heading. Elastic.
Acha. Okay. Even you can write this like one statement. I wrote in my just short terms. You can write like that. ठीक है लिखेंगे अभी
Yes, sir.
Okay. Now, simple way to understand this one again. Constant tensile stress by strain. Now, tensile means like lengthwise. Not lengthwise means this orientation. Let me draw it here. अरे थोड़ा हट जा भाई हाँ, थोड़ा सा चेंज करेंगे कलर का डायग्राम कलरफुल होना चाहिए ब्लैक एंड व्हाइट तो टीवी भी होता है तो चलो ये हो गया डायग्राम अपना now see what I did here this is stretched along the side lengthwise so this change of length is your strain and this is your fixed position and let this fixed position be touching here this is now now what we are seeing here see this area wise and all that see, this stress is like pressure only so force by area divided by strain so tensile strain means L by L that's what we wrote above also here longitudinal or tensile in this all these modulus formulas and all that it will be same only just little bit up and down formulas units will be similar stress by strain and stress by strain only unit also will be same just small differences so here if you see this is your length of like a rod which is connected in this fixed place and we are stretching from or stretching or applying force towards this direction FL and delta L which is see actually this won't be this much but just for drawing I made it stretch extra now second one shear modulus shear name itself we can understand shearing apart So if this is the object, okay, we are applying force on this direction. So it will tend to, because this is fixed. So this will tend to move this direction. Like jelly, right? If you press a jelly-like structure in this side, because one side of a jelly is fixed on our plate or something, whatever. Then if it is press, if it is pull or push or something here, so this is the position which is delta x moved. This will be your angle theta, and this is the height of that object. So where we are applying force, this direction F, and this is your fixed position. You can draw it good. My drawing is not good. I have to use some. Okay, I want to make it small. Fine, whatever. You can change it. Make it this. This position is fixed. You can make full box also, whatever to you. Okay, so this is your height, h theta. Now shear modulus, shearing stress by shearing strain, same thing. So this force Ft divided by capital A of this area, then delta x divided by h. See, one thing keep in mind, no change in volume, only shape is changing. Okay, shape is deforming or maybe increasing or decreasing, whatever. So delta x by x, we can say for theta also if you want to find angle. So theta equals to perpendicular by this. So x by h. Done? Shall I scroll it? Done, everyone? Aditi, Akshit. Akshit, done? Samhita,
Not done, sir.
Done, sir.
Yes,
Okay.
done.
Done, sir.
Okay. So chalo, last one. Can you guess what would be the last one? If you know, you can tell me.
Volume.
Bulk. For volume only. It is for volume only. Name is bulk modulus. Okay. Or B. Okay. Some book use K, some book use B, whatever. In this book is B. I'm using K sometimes, but okay, doesn't matter. It's just a variable, which is volume stress by volume strain. Khatam. Now here there is a change in volume. So where can we change in volume? Can this solid be changed in volume? Okay, actually it can be in solid also, liquid also. Okay. No need to get so much stress about this. Simple. So force by area by change of volume by volume. We can change it to this delta P by delta V by V. Force by area is pressure, negative pressure. Now same way,
Why is it negative?
because it will be like opposite. Negative sign shows that this is a change of bulk model because volume is opposite of this. In this case, here we have change in volume. Because final and initial, they might have change here. So here increase in pressure, then body of volume of body decreases. If we increase the pressure, volume decreases, and opposite. So this sign comes to make this volume or a bulk modulus positive. There is no other specific reason for that. Just simple, I want the answer to be positive. Next is your simple, like nothing here, just compressibility. Is 1 by excuse me, K, let's take it P. Compressibility is reciprocal of bulk modulus. अरे यार relation between young modulus, bulk modulus, shear. This relation we need, huh? You don't need, let it be. Okay, we'll do this at and all this relation because we need to understand Poisson ratios also. So last topic we have here, Poisson ratio. Then we'll go for some exam questions, then go for, we don't have much exam question for this, but we have exam question for this liquid. I mean, yeah. All these questions. We'll do some other exam question also, not just JEE exam. We'll do all the exam question. Okay, peeps. Chalo. Done this one. The next class means Monday. Monday we will have Poisson ratios, and most probably we'll end this chapter. Then we will have liquid. Mostly in exam they will ask combined questions or whatever possible. We'll see all type of questions because anyhow this is the last chapter. Then we'll have all the chapters like all questions. We'll solve questions, practice questions, test on any exam. And do attempt test at least. If you're not able to attempt that time or you have less time or something like that, at least later on you attempt it. Because like this question which I'm giving, it's exam questions only. I guess you can see the dates also. Okay, guys, I want you to attempt exam also every time. Your only Aditi is attending. I didn't check this time. Last test, past test. Where is it? Result. Oh yeah, same. Aditi attended. That's it. Samhita, tell me one good reason why you didn't attend the last exam.
Sir, I have pre-boards coming up soon, sir. I've been studying for that.
Even that is AC only. That is for pre-board also. You can help.
Yes, sir, I'll do them.
This exam also AC. At least attempt those which you have like board exam.
Okay,
Those
sir.
chapters you can attempt. What about Akshit? Akshit, you there?
Yes, sir.
Yeah. Why you didn't attend test last week? Tell me.
I'll attend this week.
I hope so. Okay. Shirisha,
So last exam I am not joined that time.
no, you joined that time, I guess. You didn't?
Yeah, sir.
Okay. Fine. Today we already test started. So have you attempted today's? 5 o'clock today till 5 o'clock tomorrow. Okay. It's just 20 minutes. It won't take much time. Okay, guys. Okay. Bye bye everyone. See you on Monday.
Thank you, sir.
Yo, I hope everyone will attend test.